All right, today we're going to be doing an in-class exercise related to projectile motion, and this is kind of like a classical problem in physics that probably many of you have seen before, the idea that you shoot a cannonball up in the air and you're calculating how long it's in the air, how far it reaches, what its maximum height is. And it's not really a lecture about physics so much as a lecture of translating a physics problem into an Excel solution. And so it's just applying some of the things that we discussed and that you learned about in class last time. I'll just give you a reminder about homework 4 that's due a week from today at 11 a.m. And one other announcement related to the homework. I noticed that the grader is going in and grading your homework 3, which you previously submitted online. And the way that he's grading is he's doing like all of one problem and then all of another. And so he's entering points incrementally. So if you go to the grade book and see that you've got 9 points out of 50, don't flip out. It's just probably the first 9 points for the first problem, something like that. And so wait a few days. I'm going to tell him how to make it invisible so that you can't see his intermediate work. But in the meantime, until that feature gets activated, don't be thrown off by what looks like an unusually low score on the homework assignment. I think that he'll probably have that finished grading by Thursday. So any questions about those announcements? All right. So let me show you the in-class exercise that we're going to be working on today. We've got the entirety of the class period to do it. Here are some equations, the ones that I mentioned before that may seem familiar to you if you have done the projectile problem in a previous class. But these formulas allow you to calculate how far a projectile will go. That's what this formula for x sub t is. It's showing you the position of, and by the way, if you haven't already switched off your monitor for now, will you just switch it off so that we're going to stick together discussing for no more than 5 minutes, and then I'll turn you loose to do your own thing. All right, so x sub t is going to give you the horizontal position at any time. And so it starts off with x naught, which is an initial position. So if you had some coordinates where you were actually firing the projectile from, like a starting point, a distance, that's what x naught is. And then it's v naught x. Now, the velocity of the projectile, here's a figure that shows its initial velocity has two components, a horizontal component and a vertical component. And so what you're going to be doing is you're going to be using the sine and cosine functions to find the component of the velocity horizontally and vertically. So here's the formula that explains that. And the tricky thing about Excel is Excel thinks in radians when it comes to angles. I'm not sure why they decided to make it that way, but they did. So when you have an angle, let's say 30 degrees in your mind and in a problem statement, first what you have to do in Excel is convert that from degrees to radians. And then once it's into radians, then you can put it into the cosine or the sine function as appropriate to calculate your horizontal component of the initial velocity and the vertical component of the initial velocity. So I wanted to mention that, emphasize it. Now it's in the instructions and you'll have this printout, but I thought we'd just talk about some things together to begin with. Now x max is how far that projectile is going to reach. Now t max is actually the hang time. So think about shooting a cannonball, how long it's in the air and how fast it's traveling sideways as it's in the air is going to be its range. And so this component v naught x times t max, that's the range plus the starting position, x naught. So its total distance from some origin is x max. Any questions so far about what these variables mean? All right, now in the vertical direction, things get a little bit tricky because we've got some initial position y naught. So you can think in the case of a cannonball that's maybe fired from a hillside, if you're going to be measuring the cannonball's elevation from sea level, you'd first need to keep track of its initial position, and that's what y naught is. Now, v naught y is the initial velocity, vertical component, times t, because this is going to be telling us the vertical position at any time, but then things are a little bit different in the vertical plane because there's an acceleration due to gravity. And so here we're keeping track of the effective gravity with g times t squared divided by 2. And the g that we're going to be using in this problem, everything is in SI units, so you're going to be using negative 9.81 meters per second squared, as it mentions on the handout. Negative because the acceleration is going to be opposing the direction of what we assume to be positive. So we're saying positive is up, gravity is going to be causing the cannonball to come down, and so we'll assign a negative to g. Y max is the maximum height that you can get to, and it's the initial initial height minus the effect of the velocity squared divided by 2g. And so that's the starting point, and then the minus sign here is because, remember, g is itself going to be negative, and so you'll actually have more than your starting height, but we have to cancel out the negative signs there. And we already talked about what T max is. Okay, there's one more thing I wanted to point out on here, and that is that there is you're making a plot, you're using data to make the plot and so on, and there's a starting file that has all of this formatting sort of already put together for you. So if you can switch on your screens now, and if you go over here to the main page for the website, then you'll find at the bottom of the page where it says Lecture 11 Starting File. You can just open that and be sure and save it either on your network drive or on a USB memory drive, because you're going to need to submit this in-class exercise with the homework. You don't need to upload it for today, but you will need to include it with the homework assignment that I previously gave you. So that starting file is available for you. Okay, so any questions before you dig in on this in-class exercise? All right. Let me emphasize the fact that these computed parameters aren't things that you should be typing in. They should be computed by Excel. And so you'll notice, for example, here for the angle in radians, if we go to what's typed in here, it's the Radiance Formula. Equals radians, and then the cell reference. Don't type in a number. Don't type in equals radians, parentheses 30, but rather type the location of where that number is. And the benefit of doing it that way is that then you can change the numbers in the input parameters, and everything below it will automatically update. Whereas if you had typed in an actual value, then you have to go back and change that later, which is very tedious. You want everything to update automatically. So in each of these cases, you're using a formula, and rather than typing in a number, you're typing in a cell reference. It's more precise that way, too. All right, so just another emphasis on the fact that you shouldn't be typing in actual numbers in these computed parameters. You should be using cell references. My guess is probably a third of the class will forget to do that on the exam, and then we'll get the exam problems wrong. So really, the whole point of Excel is the fact that it can automatically update its calculations based on another cell above it. Let me show you one other thing, and that's how to get these t values for the plot table. Okay, so let's say that it's empty to begin with, right? So the way that you calculate the t-step is explained, but for this formula, our first time step is 0. Can I have your attention for just 1 second, guys? All right. So the next time step is going to be equals the one above it, so the previous time step plus this reference to t-step, and I'm anchoring that because I always wanted to look at this as the amount that the time step is increasing by. And so now I can drag this down, and what it's going to do is it's going to look at, the formula will be the value from the cell above it, which was 0.15, plus the t-step increment 0.15. And so that's how it gets 0.31. And by the way, if we increase the number of digits there, it's not exactly just 0.15. And so it is keeping all the precision there in the background. So I can drag that down now all the way to the bottom, and it will keep updating the time steps that I need. And then I've previously put these formulas in, and so it's going to calculate them as well. But I just wanted to show you that t-step thing. What you're doing for the main idea there is the cell above it plus this t-step increment.